Hello, everybody. It's telling me we're live, but as always, I'm going to wait just a second to make sure I can hear myself because I don't trust StreamYard one bit. Not one bit. So we're just going to wait until I hear it. Let's see. I'm just waiting for it to load, everybody. Just waiting to make sure that I can see it on YouTube.
It'll happen. It'll happen eventually. StreamYard is notoriously finicky.
Okay, I can hear and see me moving on YouTube. It appears that we're good. Okay, so now we know that works. So hi everybody. Welcome back to Creation Myths. It's been a little while. This is Creation Myths, where we take creation scientists and creation science exactly as seriously as it all deserves. So that's what we're going to do tonight. So we have tonight a video from, when was this? This was from May 4th, so it was about 2 weeks ago, from our friend Dr. Rob Carter of CMI, that's Creation Ministries International. And he did this, I think it's an excerpt from his Genesis history or something. It's a shorter part of a bigger thing. With me tonight to go over this 10-minute clip of Dr. Rob Carter getting everything imaginable wrong is my friend Gutsick Gibbon. Erica, what is new in the world of primatology?
Oh God, not too much. I mean, there's been a couple of interesting papers here and there coming out recently, but you know, as everyone's getting their field work up and going, it's like after COVID, you know, it's been a slow trickle back into the scheme of things. I'm very excited about this though, because I love that this is Genesis history moment, because Dan Biddle is like the remora on the bottom of the creationist whale shark. Like, he is coming in, he's getting the scraps, he's getting the little bits, he gets second rights to everything. I actually can't believe he managed to get Carter to kind of appear on his Is Genesis history. I don't know if this is from Genesis Impact or which of their series this is from, but
one of their things.
We love to see it. We really do. And as Dan said, you know, this is a greatest hits kind of video. In 10 minutes, we squeeze in so many tropes. So this is going to be very fun.
we are going to fill up your bingo card. I do not, because I wanna endorse safe alcohol consumption habits. I am not going to recommend any kind of creation science drinking game for this one because you know, that could get dangerous given the density that we're going to deal with here tonight. One more note before we get into this is if you look over on the chat, you may see some new buttons right down below the chat, because I did a guest appearance on Pologia a couple weeks ago, and that bumped my sub count way up, because that turns out if you go on a channel that's 100 times bigger than yours, you get a few extra subs there. And so I'm monetized now. So if anybody feels like doing that, I'm not going to insist, but I won't complain either. So thank you. With that being said, let's get right into this. So this starts at so what we're going to do, I should maybe take a second to describe what we're going to do here. This 10-minute video, it's literally Rob Carter and Del Tackett, who DM is that's dentist, right? This guy's a dentist.
DDS is dentist, isn't it?
What's a DM?
I mean, I have no idea what a DM is. I mean, is he dungeon master? Like,
yeah, that's what I was thinking, but that's clearly, I don't know what that abbreviation means. I don't know what that means, and I apologize to everybody. If anybody wants to tell me in the chat or anything. Oh, see, thank you to Mr. Wilford. I appreciate that. And also David Neff, two friends of the the channel here. I appreciate both of you. Sorry, David, it was actually Mr. Wilford that was first, but yeah, it was very close. So okay, how do I take this down? There we go. Yes, hide. There we go. Okay. All right, so this is just the two of them talking on a dock, and they just go through stuff. Why is it back? Why it's so laggy? Oh my goodness, this computer is not great. I'm gonna have a new platform for this starting tomorrow, but riding on the old machine tonight.
What's the Hovind deal? Well, if you wait long enough, it should just evolve into a better computer there.
Don't do that again. That was good. All right.
So like this that. I'm gonna giggle.
All right. So this is So this is going to be Rob Carter and this other guy. They're going to talk in a doc. They're going to squeeze a lot of wrong into 10 minutes. We're just going to listen to it, and we're going to pause, and we're going to comment when appropriate. And here we go. Let's just do this. The nice music.
Rob, when we talk about DNA, I think most people are probably thinking about all of the human DNA now that comes up. And
just want to note, if anybody has a problem with the sound, just, let me know in the chat. It seems to be working, but just let me know.
what are we learning about the DNA of the human being?
Since we started DNA analysis, basically most everything we've learned has contradicted the standard model, the standard out of Africa idea. The idea that
Okay.
I thought we might want to hit it early. We're really coming in for the layups here, aren't we?
37 seconds. We made it 37 seconds in literally the first sentence out of Rob Carter's mouth.
It's incredible to me that these, because these are accredited individuals. Presumably when you've got your PhD in something, you're keeping at least decently up to date on the literature. So I have no idea how.
Especially if it's your job to talk about it.
Exactly. I can't even imagine how Carter's interpreting the influx of information that we've gotten over the past 2-3 odd decades as controversial to the paradigm, if you will. And he's going to get into this as this video goes on, what particular contradictions he feels exists. But, suffice it to say, this is not the case. I mean, there's a reason why science continues trucking on creating testable and accurate and applicable predictions and experiments that don't include the young Earth lens.
So let's just real quick, some of the findings that confirm the out of Africa hypothesis genetically, right, in the human DNA. We've got just the baseline level of diversity around the world. You have higher diversity within Africa than you do outside of Africa. You have more differences between African populations than you do between any other populations in the world, right? You have more diversity within Africa, indicating a series of founder events as you migrate outwards. Anytime you have a series of migrations, the epicenter of diversity is where you started. Like, that's just how migration works.
And to speak to that as well, this is corroborated by the paleontologic evidence as well. I mean, this is what we see. These are two.
That was an accurate prediction, because we said, based on the paleontological evidence, hey, it sure looks like we started in Africa. If that's the case, we should see X, Y, and Z in the DNA. And the thing at the top of that list was more diversity within African lineages compared to non-African. And that's exactly what we see. We also see all non-African lineages nesting within the clade of African lineages, indicating that they are descended from African lineages, right?
This is the classic unrooted tree issue that I'm sure we've talked about enough on both of our respective channels.
Yep.
But,
the unrooted tree issue.
There's no way to interpret the data that we have, the genetic data that we have, and suppose that you've got these 3 wives of Noah that are begetting all of these populations. This is not that kind of deal. You can't make those lines.
It's literally impossible to make a phylogeny that has those 3 nodes as 3 coexistent common ancestors of 3 distinct clades. It's impossible to do.
There's no way to get a contemporaneous, even close, by the way, to contemporaneous. We're decades separated. I think it's even a century or 2 between a couple of them. Yeah,
at least. And then, of course, you have I really like the linkage disequilibrium problem, where you have extreme linkage disequilibrium outside of Africa. You have the highest degree of linkage equilibrium within Africa, meaning within Africa, you have a high level of admixture among all those lineages.
Yes.
Outside of Africa, you have relative isolation among geographically distinct lineages. And of course, there's no way to get that pattern if you start somewhere that's not inside Africa. There's just no way to get that pattern.
That's a really good point. And especially, there's been quite a bit of recent work on this that also involves Neanderthals as well. And what does it show, right? It's this out of Africa scenario for both species, and then admixture between the two, even post out of Africa.
Exactly, and you can extend out, and by using the Neanderthal and the Denisovan DNA that we have, you can extend out that timeline to get a more and more distant most recent common ancestor for all those different lineages, but you end up with the same pattern of linkage equilibrium plus admixture, right? It is so distinct and it's so obvious. It's like a big giant arrow pointing straight towards like Ethiopia of like, this is where it started. It couldn't be more obvious. So we've been, give or take the intro stuff for 5 minutes in, we got 37 seconds before we had to stop and explain like 4 things. All right, let's see if we can wrap this up. Let's see how long this takes. All right, here we go.
Humans and chimpanzees share a common ancestor. The idea that Neanderthals are not human. There's all these things that have come up.
Neanderthals are not Homo sapiens. They have a most recent common ancestor that is way more distant in the past than the most recent common ancestor of all extant humans. This is not up for debate. It's not complicated.
We're talking about something that has been, to the extent that something can be in science, entirely precluded in several different studies. But our mutual friend Just a Walking Fish did a great job in a couple of the recent video.
We're going to make a note to link that because that was great.
Yeah, it outlines precisely what this genetic history looks like and what we've uncovered as we've been capable to sequence the Neanderthal genome in its entirety from several different individuals. And the cool thing about it is like, okay, so Neanderthals are 99.7 give or take percent similar, identical genome wise to us, but they also have like these super distinct morphologic features that separate them. They've got distinctive traits in their culture, in their biogeography, in what they hybridize with. There is no justifiable way to have Neanderthalensis as a descendant of sapiens. You can't do it.
Can't do it.
There's no way to do it. We've reached a point with this because humans are, of course, very narcissistic, where we have like looked into this from every single angle that it can be looked into. There is no way to rectify that.
You know how long we got between those pauses? 7 seconds.
Like 4 seconds?
7 seconds.
Oh my God.
All right. And we're still in the first sentence, by the way.
Come up that are completely contrary to what anyone expected.
And how do we then refute that old story of out of Africa?
In a lot of different ways. First of all, we've got DNA sequences now from thousands of people from all over the world. And there's just some things that are very clear. And the first big surprise was how similar people are from one end of the world to the other.
That's not a surprise.
So it wasn't just not a surprise, too. Several different individuals before we got the genetics, it was this idea of multi-regional versus out of Africa, right? And out of Africa was an existing hypothesis that was then thoroughly supported by our genetic studies that occurred subsequently. So it
not only was it not a surprise, it was a specific prediction of one of the two competing hypotheses. It cannot be a specific prediction of one of the hypotheses, which was subsequently confirmed, and also be an enormous surprise.
That's exactly it. And the reason is because, as you said earlier, this was a prediction rooted in the paleontology. It was rooted in the biogeography. This is what we were seeing, the patterns. And then everyone was like, all right, if this is true, the genetics should look like this. Lo and behold, here it is. But they've got to paint this as some kind of recent paradigm shift when no one in any of these fields seems to notice it. Like if evolution and out of Africa are being overturned, someone needs to tell literally every scientist in the field who's doing the work, because none of their papers are supporting that. None of the data is supporting that.
Yeah, need to tell people to stop finding all those data that support the out of Africa hypothesis, because apparently they're all fake.
The thing is, Dan, these guys aren't even doing the work that's supposedly like shifting this paradigm. They're using the leading expert work to say something it doesn't say. Like, it's not even them versus the folks who are in the field. It's them misinterpreting existing literature.
Right. And we know what scientific controversies like they are claiming exist here look like. We know what that looks like when prions were proposed, right? That was, whoa. Proteins can't do that. And that was a decades-long, like, knockdown, drag-out fight. And the people that said, no, proteins can totally do that, those people won because they had the evidence. They did the work and they showed that they were right. The same thing happened when ribozymes were proposed of like, no, RNA can't do that. No, turns out it can. And the biochemist proved that it could. And now everyone accepts that. Plate tectonics, right? That was proposed decades before it became the consensus. The people that supported it did the work to show that it was correct.
The dynamo with the magnetic field is the same way. And like the key takeaway from that sentence that you just gave us there, Dan, is they did the work. The people who are proposing it, who are proposing the shift, did the work.
Yep. All right, back to it.
That was not what people expected. I mean, back in Charles Darwin's day, he was trying to split people up into races and almost into species. Other people claim they are different species. Darwin never.
I want to be perfectly clear. One, by modern standards, Darwin, huge racist. By contemporary standards, Darwin, very progressive, and specifically argued against what Carter just said. Specifically,
he was known for being a little bit of a rabble-rouser because both him and his wife were huge abolitionists.
Yep.
Like vocal abolitionists. Do you have any idea how tough, and Darwin, of course, was a man of privilege being who he was, but do you have any idea how tough it is to be an abolitionist in like the mid-1800s? Like, this was not a popular position to hold.
Never quite went that far, but the evolutionists were trying to divide people up into tribes and clades and groups. But what we found out through gene sequencing is that people are nearly identical from one end of the world to the other.
Well, what does that commonality of genetic code across people all over the earth, what does that tell us? What do we learn from that?
It tells us tons of things. First of all, it tells us that we all came from a single small population just a short time ago. It tells.
How short, Rob? How short?
How small? How small?
I'm sure we're going to get answers to these and other questions. But
naturally,
let's just put a pin in that, because I would agree. We came from a relatively small population relatively recently. But I don't think I mean the same thing as Rob Carter means when he says that.
And bold of an evangelical fundamentalist to propose that they were the vanguard of racial equality. Like, bold of them to imply that.
Yeah.
It tells us that there's only been one dispersal of people across the planet. It tells us that the center of diversity of all people in the world is somewhere between Northeast Africa and the Middle East.
I don't even know what to say to that. That's just not true.
It's so beyond unsupported. Like, imagine, I've actually heard creationists use the phrase "out of the Middle East" before, and it's like side-splittingly funny because they always have their little sources at the bottom, and all of them are either ancient because they have to be before Out of Africa was vindicated, or about Out of Africa and then misinterpreted to basically shove the Ethiopian hotspot up into the Tigris and Euphrates River, into the
upwards, up into either, right. You get it, like you said, northeast into either the Nile basin or the Tigris Euphrates basin. And the recent finding that's been abused in that way was the hominids in I don't remember the city. I think it was in Israel. If I remember, there was a recent finding, and by recent I mean probably last decade. There was a recent finding. I think it was in Israel, might have been Jordan. I don't remember, but there were some archaic homin, not Homo sapiens, something else from an earlier thing, but they think it was one of those like little we're going to go out, but we're going to go back, or we're not going to go very far. So it was somewhere between like the main Heidelbergensis dispersal.
Yeah, I think you might be thinking of Georgia, of the Dmanisi specimens. Maybe.
I don't know. Not my field. But I remember somewhere in there was a relatively recent finding of some skeletal stuff and they were like, aha, that's the oldest. Now, like, no.
Yeah, no. It's going to be Georgia, because Georgia's kind of seated up there in the Middle East, and you've got these very basal Homo erectus. But the problem is you've got hominin populations that are bailing from Africa, small pockets of them that are bailing from Africa and seeding these other locations. There's a huge difference between other hominins leaving and diversifying and Homo sapiens doing the same thing.
Right.
There's a huge difference in those two things. We're talking species that are separated by a lot of time and a lot of genome, so to speak.
Yeah. Okay, we're almost 2 minutes in here. Let's see if we can crack 2 minutes.
So the origin of mankind is pretty much where the Bible says it was. The origin of mankind involves a small...
I don't want to linger on the point, but just no, that's not right, Rob.
Small people group, just like the Bible says. The origin of mankind involves a dispersal across the world. Everything we're learning is pointing more and more toward a biblical answer for the origin of humanity.
How do we come to the conclusion that the human race has not been around that long?
Here we go.
Well, one thing we can do is we can look at the mutation rate that we can measure in the laboratory. We can take a bunch of people that we know are closely related. We can look at their DNA. We can count up the number of differences between them. Then we say, okay, that's the rate. Now let's look at all the people around the world. How long would it take to explain all these people given the rate that we know? And the answer is a few thousand years.
All right, so he's hiding the ball a little bit here because there are a bunch of relevant words that he is not saying. And I don't know if he's not saying them because this is for a broad audience, so he doesn't want to say anything kind of technical that might be confusing to people, or if because he knows that the words that are relevant to what he's describing are wrong for what he is describing. So the main word that he's leaving out here is pedigree. And you calculate a pedigree mutation rate by looking at parents and offspring, and sometimes parents and offspring and grandchildren, and you look at the differences between them and you say, oh, parents have this many differences from the offspring. That's the 1 generation mutation rate. And then what Rob Carter is saying is you take that 1, or sometimes you could take a 2 generation mutation rate, parents, or you say grandparents, parents, and kids, and you then extrapolate that back infinitely. And this is the Nathaniel Jeanson argument, right? This is Nathaniel Jeanson's calculations for time to most recent common ancestor in the 6,000 year range. And the problem here that everybody seems to be missing is that natural selection and genetic drift exist. So when you have mutations that occur, most of them don't persist in the population. Most of them vanish from the lineage. So the relevant metric here is not mutation rate, and the units for mutation rate. This is, and I want to say this because this is technical, but I want everybody that's here to know this. So the units for mutation rate are mutations per site per replication, right? So for each site in your DNA, what's the frequency of an error in that specific site per replication, right? So it's going to be a very low number. It's like, 5 times 10 to the minus 8th, right? It's very low. Mutation rates are very low because it's per site, per replication. The relevant measure when you're doing the math that Carter is doing here, which is called calculating the time to most recent common ancestor, you're looking at all the differences and working backwards until they converge. The relevant measure there is the substitution rate, which is substitutions, and that's fixed changes within a lineage. So it's a mutation that occurs and then it increases in frequency until everybody in a lineage has it, right? That's a substitution. The relevant measure is substitutions per site per year. And it's important that it's per year because that normalizes for generation time. You no longer have to make an assumption about generation time if you normalize it per year. So the important thing with substitutions is if a mutation becomes a substitution, if it fixes in the population, then it has gone through the filters of natural selection and genetic drift, and now we can look at the rate at which genes accumulate, or at which substitutions accumulate, I should say, changes accumulate and get fixed in the population. That's the relevant rate when we want to calculate this time to the most recent common ancestor. And I'll note, he also dropped the word experimental there, implying that we can't get substitution rates experimentally, and that is wrong because what we can do is look at two human populations where we know the divergence time between them. And we have lots of examples of that. So we can calculate the differences between those populations, given the known time of divergence, figure out the substitution rate, and then just work backwards and figure out the time to most recent common ancestor for all of humanity based on the maximum number of differences. And when we do that, the answer we get, depending on the part of the genome, the most common measures you're going to see are for the mitochondria and the Y chromosome, and those fall in the 1 to 300,000 year range. And other parts of the genome are even further than that.
Yeah, we have consistently had that 200,000, 300,000 range for mitochondrial Eve at the very least for quite some time. Now, something that's important to note too is, first of all of what Dr. Dan just talked about, this idea of your phylogenetic versus your pedigree rate, is outlined in Santos et al. 2008, I believe. He was the guy who came out and was like, hey, by the way, your phylogenetic rate is always going to be significantly slower because we're accounting for, things like drift and selection and what's actually sticking around. Jeanson, who Carter's cribbing from here, I guess that way Carter's cribbing from here, knows this, and he intentionally, maybe he doesn't know, I guess I should say, it seems like he is intentionally, I don't want to mischaracterize because it's possible I'm wrong, but my interpretation is that it seems like he knows better and he's intentionally obfuscating this idea of next generation sequencing being at play. Moreover, his fast pedigree rate is also wrong because he pulls it from Parsons et al. And Parsons et al. Has absolutely bonkers sampling first and foremost. It doesn't agree with any of the other pedigree rates that come out of that time period. I think it was Hayes who got something similar, and then they resequenced it with better technology and got something that was significantly slower. But this is not like, why are we using a 1998 paper?
Parameters including things like an average generation time, not a minimum generation time, an average generation time of 15 years.
Which, by the way, Parsons had, oh God, I can't believe I almost forgot this. Parsons, the one that Jeanson is pulling from, and thus Carter is pulling from here for that extremely recent, most recent common ancestor, he has an error range that goes back to several million years. It's like,
it's
it looks like our ancestors.
It also goes as recently as a couple hundred years ago.
Right. So Carter is basically looking at Jeanson is looking at Parsons' bonkers error range, and he's saying, well, you know what? What's in between 200 years ago to, 2 million years ago? I'm paraphrasing, of course, it's much, much more precise than that. He goes, 6,000. So it's on the table. It's on the table. To my knowledge, there was nothing in Parsons at all that actually supported 6,000 years as
it was a huge range. And also everybody, Parsons, or more recently Ding et al. 2015.
Oh yeah.
I see Neff is here. We did a thing on that, talking about that Jeanson leans on. All of these authors acknowledge, like, this is a pedigree rate. It's not applicable over hundreds of generations. It's just, you can't take that rate and extrapolate backwards infinitely. That's what Carter wants to do here. You can't do it.
Which isn't
because little things like drift and selection exist.
Right. And that isn't to say it's not useful, because Parsons did have some of his methodology used by like the FBI for very recent.
Yeah, for forensics.
Yeah, for forensics. Which
we're not doing.
Yeah, go ahead. Sorry.
It's just like, God, how much time to most recent common ancestor calculations is the FBI doing?
That's exactly it. I mean, the idea that you're going to use the same methodology in recent forensics versus something that's actually incorporating things like natural selection and drift is absurd, which is why again, we try not to do this around here, but it's like, I find it very hard to believe that a geneticist like Carter, or Jeanson for that matter, would be making that kind of mistake, because they don't make their conventional work.
It's an error in the order of magnitude of trying to date, just to pull an example at random that is completely bonkers, that I know nobody would even, like, no serious person would ever try this, but it's an error of the order of magnitude of using like radiocarbon dating to try to date like dinosaur fossils.
Right. Or even using radiometric dating on like a metamorphic rock. Like
I know no creationist would be so unserious as to try either of those things.
Mm-hmm. Yeah. Only the top brass methodology.
All right, let's see where this goes.
For both the man's lineages, which is the Y chromosome, and the female lineages, which is the mitochondrial DNA, both of them give us a similar answer that people are not millions of years old.
Tell me more about the difference.
So huge obfuscation on that part. Because
strictly true.
Yeah, because that's the thing. Within our geologic time, they are relatively close together, but
they're not millions of years old.
Yeah, exactly. So, oh God.
They're hundreds of thousands of years old. They're within the same order of magnitude. It's 6 digits, and for everyone curious, the range for the mitochondrial most recent common ancestor is, depending on the methodology, like 80-ish to about 200-ish thousand years.
Right.
And the Y chromosome is older. It's like 200 to 300,000. It's possible they overlap a little bit on the margins, on just the outer edges of their ranges, with the mitochondrial one being a most recent common ancestor than the Y chromosome. And what Carter said, strictly speaking, is true. It's not millions of years. It's hundreds of thousands.
Right. And they did live potentially they did live close together, but they wouldn't have been living at the same time, right? Like
right.
they're you know, in all likelihood. I mean, that's very, very slim, but even then they're both living approximately 200,000 years ago.
And they would each be just one of many thousands of individuals, probably either in the tens or hundreds of thousands of total numbers in terms of Homo sapiens at the time.
Yeah, and
right?
that's
it's not 2 individuals; it's a lot of people.
Right. It's precisely, and the fact that is that's a slap and go situation from Carter here.
Yeah.
Like, because you're right. He's not lying there. He's right. It's just
it's not millions. Yeah. It's
like colossal asterisk right there, you know, like
different chromosomes that come as a result of being male or female. How does that help us understand this?
Because there are 2 specific small pieces of DNA that are passed down to generations unchanged. Most chromosomes, they recombine, and so the genes get scrambled. But the Y chromosome is only inherited from father to son to grandson to great-grandson. And so if a mutation occurs, it stays only in that lineage. There's this other little piece of DNA called the mitochondrial DNA that, from a lot of experiments, it's only passed on from the mother to the child. So my children did not inherit my mitochondrial DNA. They inherited my wife's mitochondrial DNA. Because of that, it's also passed, like the Y chromosome, from one generation to the next unchanged. Except if a mutation occurs, you have a new lineage. And so when we look at the Y chromosomes around the world, it is abundantly clear that they're all very, very similar to one another. And if we count up the number of differences between them, it's 500 or 600 differences. Maybe as many as 800 at the most can explain all the men in the world.
Oh.
Wait a minute. At a mutation rate that we know, we'd expect a couple of mutations per generation. That's only...
Once again, mutation versus substitution rate. Mutation rate is not relevant to the question of time to most recent common ancestor, because most of those mutations are going to be lost within a few generations.
This is a very accidentally or intentionally strategic way of explaining things. This idea of putting, broadly accepted truths and then changing the interpretation of them, just ever so slightly, and not explaining the methodologies by which we got the truth versus what he's imposing on it. That's so dicey.
Only a few hundred generations. That's biblical time frame right there.
No, it's not.
For the mitochondrial DNA, most people in the world are about 20 to 25 mutations separated.
Here's another thing. When you're doing time to most recent common ancestor for the population, what matters is not the average difference, it's the maximum difference. So he's using a lower measure than he should be. The average between any 2 people, you take 2 random people, you're going to get between 20 and 30 mitochondrial differences. On average, that's what you would expect, just picking 2 people at random. But the maximum is about 120. That's what's relevant. So even at the wrong mutation rate that he is using, he's using the wrong mutation rate, but he's also using too few differences to get your 4,000 to 6,000 year answer, right? For mitochondrial convergence, it would be 6,000 years because it would be Eve, because you have 3 through the flood. For Y chromosome, it should be the flood should be your most recent common ancestor at Adam, or at Noah rather. And so he's actually using both sides of this math wrong. The rate is wrong because he's using mutation rather than substitution rate, but he's also using the wrong number of differences that you have to account for. He's saying 20 something. The actual is 120 something. So even if you spot him the mutation rate, he's still off by a factor of 6.
he's using the wrong methodology, and then he's actually getting the wrong methodology wrong.
Yeah. Mm-hmm.
From the mitochondrial ancestor, Eve. Well, that's just a few hundred generations.
So what we're seeing here, there's a stark difference between a genesis paradigm approach to how man began and how long he's been around, as opposed to the conventional paradigm that says man has been around for millions of years and in various stages.
No.
I mean, man, if you're talking genus Homo, right? Like,
if you're talking Homo, then you get what? What's the consensus now? Like 3 to 4 million years, maybe something like 3-ish million years.
Oh, yeah, it really depends on the interpretation of like some of our really potentially early members.
Not a rabbit hole we need to go down now, but I should definitely consult with you before I have my evolution summer class coming up, and before I do human evolution, I should consult with you. I think I've been using about 3-ish million years, but I should make sure I'm up to date on that before.
Yeah. I think you're good. I think that it really does depend on just some of those really, really old potential.
There's some borderline cases that are really chimeric in terms of their traits, and you're like, what genus?
Comparing late Australopithecines with early Homo, I mean, that's like comparing almost purple with almost purple, right? It's like
it's that wonderful red to blue paragraph that people use to explain macroevolution. It's at what point did the text turn red, and it's like, I don't know, it's a big purple in the middle, but it is a gradient, and so
exactly
not a rabbit hole relevant for right now, but a fun rabbit hole nonetheless.
Yes.
Ages. And what you're saying is the genetics don't seem to support that.
The genetics, if we use real-world mutation rates measured in a laboratory, the genetics indicates that man is very recent. But there's another factor we also have to account for, and that is what happens to mutations over time in a population. See, every child that's born has more mutations than the parent was born with. That means that every generation is actually a step down from the ancestors. And at the rate we can measure, 60 to 100 mutations per generation is a nice average. At that rate, we will go extinct before millions of years happens.
So there are really two.
I forget. Erica, do you remember if he actually says genetic entropy? Because that's what he just described. He just described genetic entropy.
I don't think he discusses I don't think he actually uses the word genetic entropy. I don't think that, because I might be confusing it with the fact that I know he doesn't mention Tompkins. He
doesn't say Tompkins, but he makes the Tompkins argument, right?
Right, he does the Tompkins, exactly. So I don't remember for sure.
So we're going to find out, but this is what he's talking about right here. Straight up, this is genetic entropy. He's describing genetic entropy, my favorite wrong creationist argument. It's bad for literally every reason, and we'll see how in-depth he goes before we talk about it briefly or not. We'll see. It's already 9:40, and we're not quite. We're over halfway through, so we'll see.
Ways to look at this issue. One is how fast the mutations are changing, and because of that, we can't have been around that long.
That's right.
But if we have been around that long, that mutation rate would have
killed us.
We would
be extinct. The standard model, the evolutionary model, requires that mutations are removed over time. But there's not enough time. There's too many mutations, and it overwhelms them mathematically. Back in the 1950s, this famous...
Oh, here it comes. Here it comes. He's going back to the 1950s. I think some of you know what's coming.
Only the most
scientist named Haldane. He said that if there's as many as one mutation per every 10 children, we're guaranteed to go extinct.
Okay, so that was Haldane's dilemma, which was a theoretical exercise in population genetics, purely as obviously this is not the case. Why isn't it the case? Because we're not extinct.
Mm-hmm.
So clearly this theoretical dilemma is not an actual problem. And you'll notice he said it was from the 1950s. I don't know if anybody is familiar with the history of the field of evolutionary biology, but some things we didn't have in the 1950s. Neutral theory. We didn't have neutral theory in the 1950s. So as best we could approximate, you know what we also didn't know early in the 1950s? The structure of DNA, the genetic code, how DNA was replicated. We're invoking a dilemma from before the field of genetics as we know it existed, right? And we're going to say this is relevant in the year of our Lord 2021. Are you kidding me?
It would be almost akin to talking about like how to best combat miasmas, like bad air that
right.
Like and using that somehow in discussing modern medicine. It's just completely
right
inapplicable to the modern field. Oh God, and it's so classic because we talk about it on this channel and we've talked about it in other mutual channels, Stan, but it's like the arguments that they're using, they're always 20 to 50 years out of date. In this case, 70 years.
70 years off.
Just incredible.
Yeah. It's so before I think they're about to kind of change gears a little bit. So I just want to take a second. The argument that Dr. Carter's making here is genetic entropy.
Yep.
That you've got mutations occurring each generation. They're inherited from parent to offspring. And because most of them have such a slight impact, you can't select them out. But they still have a harmful impact. So over time, the genome degrades. Now, there are a lot of problems with this idea. I'm not going to do the 20-minute version right here. I'll do the 2-minute version right here, because here are the assumptions that underlie genetic entropy. These are the ideas that must be true for genetic entropy to work. And he just said a minute ago, we've done the math on this. No, you haven't, because I've read John Sanford's book, that Dr. John Sanford, plant geneticist, who came up with the idea of genetic entropy. I've read his book, and you know what there isn't in it? Population genetics. There isn't any math in it that explains how his idea works. So here are the ideas that need to be true for genetic entropy to work. 1, all mutations need to have a fixed effect on fitness and cannot be context dependent. What is good right now must be always good, and what is bad right now must be always bad. Right, that's one.
Which violates the basis of natural selection, by the way.
It's always context specific. It's something as simple as the population size changes the margin of what will be selected for and against. It's always context specific.
Easily so. Like that was Darwin's entire observation.
Right.
Is that different like, with the finches? It's like different situations favor different traits.
Right. This peak is bad if I eat little seeds, but it's good if I eat big seeds. So if there are more big seeds, then we're going to have that's the whole point, is that it's context dependent. Okay, so that's 1. 2 is that almost every mutation is harmful in some way. He says in his book, there are virtually no truly neutral mutations, and there are virtually no beneficial mutations. He actually draws a distribution, and he draws a teensy little curve for beneficial, and then says, but that's a misrepresentation. I can't actually draw it small enough to be accurate. So he virtually no truly neutral or beneficial mutations, but at the same time, that frequency of virtually 100 to 0 in favor of harmful must also be constant over generations, which is contradictory with item number 1. Every mutation has a fixed effect, because if you take a bad mutation and it occurs, right, if you go from the good state to the bad state, now you've changed the distribution because you can flip back, right? You've changed the relative frequencies of good and bad. So right away within his premises, you have contradictions. Right. And then the final thing that must be true is that you have no differences in relative fitness within a population. So everybody is declining, and everybody is declining equally. So they're equally enough that there are no selectable differences between individuals. So you can do nothing to arrest the slide by getting rid of the worst genotypes within the population. All of those things must be true for genetic entropy to work. None of them are true.
And to be very clear, those 3 criteria are how Sanford actually defines it in his own book. Yep. This isn't Dan saying, this, presuming X, Y, and Z, this is the criteria. Sanford outlines this.
If anybody thinks I'm being mean to John Sanford, go read his book. I encourage you to do it. And I've actually had debates with people where I've said, here's how bad this argument is. And other biologists, other people who oppose creationism have argued with me over that, being like, he didn't actually say that. I'm like, no, it is actually that bad. People do not believe me when I explain this to them until I start quoting from the book, the part where he says these things. It's right there in black and white.
And again,
it really is that bad.
The concerning part about this is most of the Sanford, I haven't looked at Sanford in particular, but I feel comfortable asserting this idea that, he's got this PhD, he's probably done conventional work he had to have, in all likelihood in order to get
patents.
that.
Like, he's a legit geneticist.
Right. So what exactly is going on here in this text that he's got? How is this representation like copacetic with his qualifications? Right. I don't know the answer to that.
Being charitable, being trained in molecular genetics is very different from being trained in population genetics. And genetic entropy is fundamentally about population genetics, right? So if you are a molecular geneticist, right? If the nuts and bolts of how things work, and I mean, one of Sanford's most well-known inventions, the gene gun, a way of making, recombinant crops, right? That's what you would make transgenic plants that way. It's an older technology. We don't use it anymore, but it was a big deal at the time. And he deserves credit for that, but that's like a really hardcore, molecular thing. It's not a pop gen thing, right? So to be charitable, it is two different fields.
Well, curious that most creationists don't tend to actually argue for young Earth creationism within their own field. They tend to hop into an adjacent field, something that's just close enough that they can claim, some kind of expertise in it. And that, something very similar went down very recently with our friend James Torr, who is a synthetic chemist, but he's talking abio, which is very different. Those two things are not analogous, right? Otherwise, he'd be doing origin of life research, or his patents would have applicability to it. But yeah, I think I want to take the charitable interpretation as well, because you're right. The gene gun was huge at the time. Sanford's done good work, so I don't understand why genetic entropy is such a poor text.
All right, let us move on.
Well, it's about 100 per child. That's 1,000 times worse than the worst case scenario they can handle mathematically.
And what you're saying then is that this evidence really is pointing back again to the biblical historical record.
Absolutely. Absolutely. When we look at just people all around the world, they're so similar to each other. It's clear we came from actually an atom. So little me, like I used to have a red beard, right? It's all white now, but this red is a mutation. It's a broken gene. I don't have brown hair anymore, or the skin color that one of my ancestors picked up. This is a broken gene. We even know where gene is. We know what letter change happened in that gene. And all Europeans share that skin color. It's a broken gene. So we need a little bit of genetic diversity, 6,000 years of mutation, and we can explain people with no common ancestry to chimpanzees. We don't need millions of years. We don't need evolution.
Concerning the
I just want to point out that what he just said is directly contradictory with the argument that Carter has made, and not just verbally, but in peer-reviewed creationist writings in favor of created heterozygosity.
Yeah, Carter's put this in text. Carter has put this in text.
Yeah, he's made this argument of mutations don't do it. It's all about starting with a lot of diversity, and then the recombination rates do it. And Jensen has the most fleshed out math on this, where he said over 99% of all diversity is based on pre-existing diversity followed by recombination. It's his CHNP hypothesis, created heterozygosity in natural processes. And I actually have a video doing math on that. The math doesn't even come close to working. Carter, he has a paper with Sanford. He didn't formalize it as much as Jensen has, but it's the same basic argument.
I mean, lest we even touch, I know created heterozygosity is another entirely different animal, but lest we even touch on the size of some of these genomes for and the classic example that's always given is like chiropterans, right? In order to explain the diversity of all bats that we have today, your progenitor genome, with the built-in diversity for everything that they would eventually beget, is a physically impossible structure. You can't have it. This is not doable. It is ungodly large.
We know what recombination rates are. We know how many alleles we have for different genes. The example I really like is the ABO blood group. There's over 1,000 alleles. We know what mutations are there. We know all the variants. We know what the recombination rate is. We know how big its chromosome is. You can do the math and just see, given what we know about recombination rates, how long it would take.
Oh yeah.
And it's a long time to get all those different variants just by recombination. It's a long damn time.
Oh man, and the thing is, he's about to go with our boy Tompkins. I'm really excited.
Here it comes.
Concerning the chimpanzee, the conventional paradigm tells us over and over again that we have like 98% similar genetic code with the chimpanzee. Is that true?
Here it comes.
It is absolutely not true that we're 98% identical to chimpanzees. Some of my colleagues have run.
I just want to point out that as we were watching this, so this was a premiere a couple weeks ago, and I happened to be watching this live, and at the same time, Erica was watching it live, and our mutual friend Just a Walking Fist was watching it live. We were all happened to be watching at the same time. And as he said this, all three of us in the chat at the same time, all three in a row said, "Oh no, don't say the Tompkins thing." Right away. It was perfect.
I love to.
And look who's here. And look who's here. We have another guest with us. Hang on. Let me just get. I don't want to hit it more than once. There we go.
Hello.
Welcome, Dapper Dinosaur. Welcome to the show.
I'm just in time to catch like the last 20% of this video, huh?
Oh no,
I'm sorry.
You're just in time to catch my favorite part because
Oh.
we have alluded to our mystery friend Jeff Tompkins, who I love so much. I think Tompkins is a perfect example of the theme that we've been harping on this entire time, which is people who have credentials doing things they should know better than to do.
Right.
So let's hear it.
Run the numbers. And when you just take a piece of the chimpanzee genome and look at the human genome, you get about 80% identity. And when you do the reverse, you get about 80% identity. Because 98% was a myth.
No.
When they sequenced the chimpanzee genome, they didn't want to spend $3 billion on it. That's how much.
So who wants to take this one and explain? I'll just say that I am not an expert in the human chimp stuff. That is not my specific thing. But I know that this is like Tompkins' thing along with human chromosome 2, which I don't think they get into here. But oh my goodness, we could do a whole hour on Tompkins and human chromosome 2. So my understanding is Tompkins butchers the numbers to get like 80 to 85% and take it away. Tell us all this wrong stuff that Tompkins did, because that's what he's alluding to here. He's talking about Tompkins as the colleague.
Okay, so the history behind this is actually very fascinating, because first you've got Tompkins coming out with this 70% number, 70% identity. And when we're talking comparative genomics, we're taking the human and the chimp genome, and we are comparing them alongside each other and looking at the sequences of the genome, the bits that match. So he comes out initially, Tompkins does, and he says this 98.8% of coding base pairs and 96%-ish of non-coding base, including non-coding base pairs, is not correct. It's actually 70%. Now, keep in mind, the chimp genome was sequenced in 2005. I've actually talked to Steve Schaffner, one of the guys who was on that paper. I corresponded with him and kind of discussed all this with him because it's a very interesting topic. I think it's interesting in and of itself. So Tompkins publishes the 70% number, right? Enter Glenn Williamson, Ruhif. He's a computer guy who has a passing interest in comparative genomics. And he notices that the version of BLAST, which is a sort of rudimentary comparison tool that Tompkins is using, is bugged. It's got a huge bug in it. And so it's actually giving incorrect numbers to the point that when you compare two identical humans, you get about 70% of comparative identity using Tompkins is using. Which, of course, is a gigantic red flag. So Glenn reaches out to Tompkins, who is the sole, at the time, the sole peer reviewer of Answers Research Journal. And he's like, hey, your work is bad and feel bad.
Hold on. They only had one peer reviewer for the entire... Don't they try to publish things in a whole bunch of different fields?
Yes, and it's just Tompkins. Yep. At the time that this was going on...
Oh, my goodness.
Tompkins. I don't know if that's still the case, but at the time this was going on, it's just Tompkins. And so Glenn
the fact that it was ever the case, as far as I'm concerned, completely validates Answers Journal from ever being considered even remotely approaching any actual kind of valid peer review. Like, just no.
I mean, we could talk about all the reasons Answers Research Journal is bad all day.
Well, we could do a whole other hour on that.
Right.
Fair enough.
So Glenn comes out and he's like, you're using a bugged version. And also here are a bunch of other issues that you've got going on. So Tompkins, actually to his credit, is like, hey, everybody, I'm using a bugged version. Here's my new numbers. It's 80 to 84%. And at first, the sort of creationist community was like, this is great, really good job, and they really back him. You go back and you're looking at this back in like 2015 when he comes out with the 80% number, and you're reading all these original articles, like Weil as a classic example, has come out, and he's like, yeah, this is really good. And like within a week or so, Glenn Williamson comes back out, and he's like, so we've got a couple of issues here. Our geneticist friend Tompkins isn't actually weighing any of the segments of the genome. So a segment that has 60% similarities between a human and a chimp that's maybe 100 base pairs long is essentially being weighed as the same as a 1.5 million base pair sequence that's 100% identical or 98.8% identical. They're being they're considered equivalent, and of course that's automatically just not at all how math works. Like that's not even a genomics thing. That's not how you do math. But it gets worse because Tompkins also would take segments like within this larger scale mistake. He would take segments that are about, let's say you've got 300 base pairs of human versus chimp, and there's an insertion on the chimp, so everything is shifted by 1 at the 150th mark.
Right.
He would consider those 50% identical because after the insertion event, everything is staggered by 1. Whereas alignments, which are a crucial part of comparative genomics, are used when we're comparing 2 humans to one another. Okay, like this is how the same logic, of course, is used in like paternity tests. So Tompkins gets it wrong on pretty much every front, to the degree that Weil and several different intelligent design websites came out and were like, we're gonna kind of wait on this one. Like they were like, there have been some things out about Tompkins's work, and we understand these criticisms, and we think they're good criticisms. So we're gonna wait till Tompkins revises it, and then like with all that in consideration, his mistakes in order, and then reassess it. And Tompkins just goes radio silent. He hasn't put out another number since, at least to my knowledge.
The analogy I like to use there is like, okay, suppose you and someone else both have copies of the same translation of the Bible, but yours is missing one of the A's in the word Aaron, a name that occurs pretty early on in the Bible, and that's the only difference. According to Tompkins' math, your Bible and the other guy's Bible are only going to be compatible about 10%.
Yep.
That is insane. Yep. No one would take that seriously.
No, of course not. Which is why no one did. Not even in their own camps was anybody like, yeah, this seems legit. Like really excellent work, top marks. And I just think it's very interesting that Carter here, and again, perhaps it's rooted in the time that he's got, because this is a short segment. But Carter's not like name dropping Tompkins or anything. Like he's not saying
He's done that 3 times now. He didn't mention Jensen. He didn't mention Sanford. He didn't mention Tompkins.
Yeah. So therein lies the
I mean,
it makes
generally don't cite sources overall. So why even bother citing each other, right?
Right. And I mean, again, Tompkins' whole deal too. He touches a lot on human chromosome 2, which he thinks is not a fusion site. That is indefensible. I mean, like that is not a defensible position to hold at this point. Which is why he's kind of up on it, especially with the Alphoid repeats works that have come out.
But there's a telomere-specific gene near the fusion site. That, for some reason, that negates the entire idea that it's a fusion site because...
Yeah, dude. The highly functional, barely distinguishable from noise, DDX1102.
Mm-hmm. Shall we continue?
Yes.
Yep.
Let's do it.
First human genome. In order to sequence a genome back then, what they would do is they would randomly sequence lots and lots of little pieces, about 300 base pairs long.
I just want to put a pin in the phrase back then. I just want to put a pin in that. Back then.
Okay.
And then they would line them up. They use a big computer program to line them up. Mm-hmm. And if you had enough pieces, you'd fill all the holes. And you have to sequence it about 30-fold over. And then you have enough to make sure you don't have a gap. Oh. When they did the chimpanzee genome, they sequenced it 5 times over and lined it up on the human genome. So they assumed common ancestry without ever testing it, and they made a Swiss cheese genome. There are so many holes in the chimpanzee genome, it's not usable. So several.
Can we put a pause? Yeah, so God, first of all, like forgetting the fact that again, that's how comparative genomics works. That's how we do it with everything. The second issue is if Carter wants to take the position that because there are gaps in the chimpanzee genome that it's not fully sequenced, then there has never been a fully sequenced genome. We pumped billions of dollars into the human genome sequencing, and by Carter's definition here, it's not fully sequenced because there are actually larger gaps, at least according to what I've seen, there are larger gaps in the human genome than there are in the chimp genome because there's so many just short tandem repeats that we find in the human genome that are just they don't do anything. They to our knowledge they do nothing. Because you can mess with them and the organism is perfectly fine as exemplified by like knockout mice, etc., which I think is another great example of genetic not being a thing, genome functionality and ENCODE just not having a dog in the fight. But like I don't know how much I can stress that that's how comparative genomics works. That's how we do it when we compare two people. Like we look at highly variable regions and we compare those. Right, that's the name of the game, and that's how we compare different species that would be considered even by creationists to be very closely related. We do it exactly like that. So I don't understand where the gap is here for Carter.
Well, so I have a question, and maybe I'm just misunderstanding this. Is he complaining about the idea that matching up 300 base pair long DNA segments is he saying like that's not a valid thing to do? Because I just went and checked and let's say that you had these 300 base pairs sections, right? If you could max 200 of them, the chances of that just being a coincidence is 1 in 2.5 times 10 to 120th power. That's the kind of coincidence level we're looking at here. It's not coincidence.
Yes. So the problem there is where you have lots of redundancy in the genome and lots of repeats, it becomes difficult to figure out which, if you have a repeated thing, it becomes difficult. You have to use like the little bits on the end that are non-repeated. So in order to get good resolution on there, you need to sequence those flanking regions of the repeats a lot of times so that you can have really good confidence that when you take this specific thing that repeats 50 different times in 50 different places, you have to like be confident that it belongs on chromosome 1, and then this other one that I sequenced is actually the one on chromosome 9, and this other one is on chromosome 12. Right. So what you want to have is what's called deep sequencing coverage. You want to have the same area sequenced just a little bit offset as many times as possible.
Right.
And
it just seems like his complaint is silly, given
this is why, so he's complaining about a common technique called scaffolding, which is when you have a known genome that you've done the deep sequencing on, and you have a genome that you hypothesize is going to be very similar. You can test that prediction by aligning it to the deeply sequenced known genome and seeing if they do actually line up in the way you predict. Now, there's two things here. One, that's a confirmed prediction, so awesome. Two, this goes back to when he said at the beginning, at the time, right? He started this by referencing when we first sequenced the human genome. Guess what? It's gotten faster and cheaper and easier since then. So now when you sequence something, you don't sequence it to 5 or 10 or 30 times coverage. You can sequence a region to 1,000 times coverage just as fast.
Well, and to this end, we've been able to sequence the genomes of other organisms and add them to the list. So we've got the drafts of other hominoids, and a paper came out I can't believe I forgot to mention this. A paper came out just last week that resequenced the bonobo genome. Right? We've gotten a higher scale of the bonobo genome, and they found a higher similarity than 98.8. It was marginal, but it still went up again. So the higher the technology, or the more the technology advances, the more specific we're able to get, and the more we're able to narrow it down and get into the nitty gritty of this kind of stuff, and the less different we find that we truly are. I suspect very soon that there's going to have to be another pivot to it has to do with epigenetics or something along those lines instead, which of course will run into.
Don't open that can.
Yeah,
I've yet to hear a creationist give me any explanation as to 1, how epigenetics works, 2, why it's a problem for evolution, or 3, anything that resembles a coherent argument at all. They just use it as like a magic on, be like, aha, evolution, epigenetics does a thing somehow in a way that makes you wrong, I think, maybe.
Okay.
The thing is,
let's not go down the epigenetics rabbit hole though. Let's
go ahead.
stick with Carter. We have about
That's
a
fair.
minute and a half left. Let's bring this train home.
Home stretch.
Several years later, someone went back and they only resequenced just the Y chromosome.
Oh,
And it turned out to be radically different.
Oh.
The Y chromosome in chimpanzee is half the size of the Y chromosome in human. And of the half that they share with us, it's only 70% similar to the human version. The paper that
take it away, Erica.
Yeah, so the really fun thing about that is, one, so chimpanzees are subject to wild sexual selection, which leads to just incredible differences in their Y chromosome. But that's not the important part. The important part is chimpanzee subspecies differ wildly from one another on their Y chromosome, because they are subject to these wickedly high mutation rates because of, in part, their mating systems. This is classic for organisms that have this polygamous mating system fission fusion society, because they're mating with one another all the time. There's a huge emphasis on, for instance, on sperm competition, which is like the primary genes at play in these rapid mutations.
Excuse me, can I just ask what makes you qualified to comment on that specific phenomenon?
Oh, wait. Yeah, you're right. Sorry. I'm not a geneticist. Let me clarify.
I was alluding to that being like the topic of your master's thesis.
Oh, you were talking about my master's thesis being primatology related, a master's of research in primatology. Yes.
And having to do with mating systems and differences in the sexes based on the mating system.
Well, sexual dimorphism, yes, and specifically with relation to, tangentially speaking, the genes that are at play in the differences between male and female canine tooth size, which are, of course, very similar to, in the relation to the Y chromosome, testes size and volume is sex specific. Which is very interesting, and that's a great question. Very applicable.
Erica,
yeah.
Just because you extensively study something doesn't mean anything, because some guy on the internet who read a book somewhere and misinterpreted a couple studies says you're wrong.
Well, listen,
and also you're not a geneticist.
That's
true,
that's
the thing. I've been told that I can't speak on primate genetics because I'm not a geneticist, despite the fact that my degree is in primate biology, behavior, conservation, and evolution.
And was the person who told you that a geneticist themselves?
Them's the breaks.
Oh, it's so funny that you asked that, Dapper, because the answer is, of course, no.
Weird.
In fact, ask me if the individual that asked me that has a degree in anything.
Does that individual have a degree in anything, including selling used cars?
I don't know.
Interesting.
We have 1 minute left. We are so close. We have 1 minute left.
That did it. They said that was as much difference as we expected between man and something like a chicken.
Well, for sure, what we know is that the human being is radically different than any of the other animals that we see around us.
Other animals drink.
It's only the human being that can create
other animals. Look, if he acknowledges we're animals and we're mammals, then like, why can't we be apes?
It's the same exact logic. And I want to touch on one last thing with the Y chromosome stuff, because I want to make it very clear.
Please.
Again, the difference that he just talked about that makes humans like radically different from 70%, that's the difference between we'd expect from a chicken. Okay, by that logic, then two chimp subspecies or chimps and bonobos aren't related. And I don't know any of them that would say that.
Well, and
their differences are enormous in the Y chromosome because they're all a part of the same lineage experiencing these rapid mutations due to their social systems and mating styles.
There's also one thing I want to point out, which is that he just said, oh, this is the same level of genetic difference that we would expect between, say, a human and a chicken. The thing is that creationists themselves, I think, fairly say, well, one thing is whether or not we have, independent origin or common origin, very similar morphologies and, biology should result from similar genetics. And, that's fair enough. I think there are other things like neutral, like sequencing non-coding and sort of non-functional parts of the genome and like ERVs and stuff that just get rid of that objection. But right here, he's just saying, similar morphology doesn't result in similar genetics, apparently. Because if you're saying that chimpanzees are supposed to be as close to humans as chickens are, then you cannot also maintain that similar genetics results in similar morphology. But we all know that the phenotype is a result of the genotype, so it has to. So you got to pick a lane, dude.
Mm-hmm.
Like, you cannot
good
hold
point.
both of these things simultaneously. They cannot both be true.
But, and bear with me on this one, epigenetics.
Oh, yeah, good point.
Check.
I forgot.
Pack it up,
Checkers, mate, evolutionists.
There's going to be a
Technique
difference.
evolutionists, pack it in, boys. That's it.
There's going to be a difference
All right.
in which parts of the genome are methylation targets or whatnot, and that's going to prove no evolution.
See, there you go. All right. Let's see if we finish strong here. Let's see how this goes.
That scuba gear that I was wearing to keep me alive underneath the water.
That the humankind is the only kind, the only species that God created that has the capacity to wonder and marvel about the world that God created.
Oh my God.
Well, I want to learn more about them. But in the remaining time, maybe we can do some more underwater stuff. Huh?
The weather's really nice. Let's go on another dive.
Let's do it. So,
Underwater stuff.
what would I be doing on my next dive?
I mean, I don't blame them. That does sound like fun.
All right.
That's like
That's
okay.
it.
You know what?
Yeah.
I'm okay with saying, yeah, humans are the only species that have like I don't know, like crises of like no one else has existential crises, right? Like, you're not about to go find like an aardvark who's sitting around like contemplating the meaninglessness of life in the face of a universe that's most likely just going to end in heat death, and how ultimately nothing that they do is going to matter in a billion years. Like, okay, I get it. Humans are weird like that. They're basically like if you took chimpanzees and just dumped enormous amounts of anxiety on them for some reason.
That is
But
my
I'm not
average
sure.
I the thing that gets me though is like also you really can't even say that we're the only ones that marvel and wonder at the world around us. I can't even imagine what that would look like, how you would manage to test that. I mean, to our knowledge, other organisms, particularly primates, but cetaceans and chordates sometimes too, they've got a broad range of cognition. And because they're social like we are, so much of their sociality and bonding comes with communicating with one another. Now, are they communicating about things as complicated per se like we are? Perhaps not. But at the same time, we lack in many ways some of the complexities of their social organizations and of those of other animals. For instance, we're horrible at communicating with scent. Our noses are effectively worthless when it comes to sniffing things out, as is the case with many primates. But the complexity, like, I hate this human exceptionalism thing that tends to run around in the creationist circles, and unfortunately, in a lot of the general populace as well, this idea is that humans are uniquely special. All organisms have something about them that makes them uniquely special. They all have their abilities that allow them to exploit the resources that they exploit, or live in the ways that they live. So this
in
idea
some ways, that's what it is to be a species. If you weren't unique compared to other species, then how are you validating drawing a species line there?
In some ways, yeah. So it's like I just I mean, the example that I always like to use that Dapper and I have mentioned a couple times is like, okay, you want to talk about species uniqueness. Like, mantis shrimp have 12 cones. They can see more colors than we could even imagine, and more wavelengths than we can even imagine. And that makes them unique.
And they can punch water so hard it lights up.
They can do that.
It's one of those things where you don't even think that's a thing that's possible, but they do it anyway. They make flashes of light by punching water really hard. And the real quick point I wanted to make about human exceptionalism is, even if you accept that humans are exceptional, it in no way negates common ancestry with non-human animals. Because even if humans were uniquely, amazingly awesome or whatever, that does not logically disconnect them from other organisms. It just means they're different in these ways. But we also all know that we're not different in many ways. Just there's so many similarities between humans and any other animal that you care to name that goes so deep, like biochemical pathways, but of humans at a basic level are just the stock standard generic eukaryote biopathways. Most of the stuff that's going on,
eukaryotic cell,
the chemistry going on in a human cell is almost exactly the same as the chemistry going on in a dandelion cell.
Yeah.
I mean, it's
with the notable exception of the whole carbon fixation thing, but
right.
Other than
But
that.
like most of the various chemical pathways that are going on, there are some big differences, but most of the chemistry is doing the same stuff.
I I think that is a great place to put a bow on this concept. So, Erica, any final thoughts on this waterfall, this deluge of misinformation from Dr. Rob Carter?
This is going to be my new go-to greatest hits for creationism and modern arguments, because we really did hit all of them. I love it.
Yeah.
I love it.
Dapper, any final thoughts?
So I just want to give my bit of this video is when he says, oh, from mutation rates that we can measure in the laboratory. And I sit there and think, you can also measure replacement rates in the laboratory because we have access to DNA from dead individuals from thousands of years ago in places where we have historical records as to how long ago they got there. This is not a non-measurable thing. Yep. So we can compare mutation rates to genetic replacement rates. And guess what? They're not the same.
Yeah, they love the word. They love to throw around empirical and put that in front of mutation rates or pedigree rates. And no, we can directly measure substitution rates too. We can. Those are just as empirical. Yeah.
Yeah. And that's my favorite bit.
My takeaway from this is, and this is like, and it's been a journey from, and I'm well, I'll give a quick note in a minute, but my takeaway from this is that the pros here, and Dr. Rob Carter, this is a man with a PhD. He's a professional. He's a marine biologist. Like, he's done the work. He's got the expertise. His arguments are not better than like the randos on YouTube or like the creationist subreddits. Like, they are the same arguments. I think the difference is it's the professionals is where the arguments originate, but they are not better when they come from Rob Carter compared to some random person on YouTube or Reddit or Twitter or wherever, right? It's all the same thing.
He's basically using his degree to write biology fanfic, and then other people are riffing off of that.
It's biology. That's a great way to put it.
Yeah, and you can be an expert in certain areas and make bad arguments when you step outside of that zone. Like, that's not to throw shade on individuals who worked hard to get their PhDs. It's just to say the arguments are not good in this light. I mean, they're not.
Have you heard of the Nobel Prize syndrome, where Nobel Prize winners then kind of get a big head and go into areas that they're not an expert in, and get off the walls bonkers crazy
all the time? So examples of that where like people who came up with important, groundbreaking ideas just lost the thread at some point and went full woo. And that's happened a number of times.
We're just seeing a lesser version.
Dapper, anything coming up? Any news you want to share? Anything coming up on your neck of the woods?
So let's see. I just released a video today. So it is my second part in a series. It's going to be 3 episodes about Jordan from Spirit Science talking about alien conspiracy theories. And that's been just a wild ride, because if you know Spirit Science, you know it makes young Earth creationism seem pretty normal.
No, that's
basically what Spirit Science does. It's amazing.
A powerful.
Yeah. The next thing I'm definitely going to do is Sunday, I'm going to be on Stupidity is Not a Right on Fight the Flat Earth's channel, or FTFE as he's going by. Then Tuesday, it's going to be a Kent with Bent, and I am on recommendation. I'm going to see if I can't get an extra guest on that. I did ask one person, but I haven't heard back. So I might ask a few other people if I don't hear back in the next few days. So we might have a 3-person panel for Kent with Bent. And then the Thursday after that is going to be the finale for the Spirit Science. And at some point this month, I think, I'm going to have a guest video released on Vice Rhino's channel. So stay tuned for that.
I don't know how you maintain that schedule, but power to you.
Erica,
what do you have
yesterday?
coming up?
I worked about 20 hours. That's how.
Erica, what do you have on the horizon?
Yeah, not too much stuff. I had kind of a busy week this week and last week with releasing videos, but I'm trying to maintain a-ish schedule. I try to get 2 somethings out a week, but it will. I am of varying levels of success to that point. But I got some stuff coming out this week. The only last thing I've got going on this week is tomorrow I'm going through 2 papers, or I have gone, and the video is uploading, through 2 papers on the evolution of human eccrine sweat glands, and on how we maintain being the most efficient ape with regard to water conservation, which is really cool. It's just like a human evolution video. It should be really fun.
Nice.
Next week, I'm having I should be releasing a video on philosophy of biology. Danny's helping me out on that one. He's in the chat. And we love Danny. I love Danny. I will say that. And other than that, I should have another bite-sized bust out next week. And then on that Friday, I'm really hoping to get out a video on the KPG extinction, but we'll see.
That
Awesome.
sounds great. And I want to just throw an endorsement out there for the Bite-Sized Bust series. I love that series, and I've learned so much about I've learned the elevator pitch refutation for so many things that you hear. It's just the recent one on so-called polystrate fossils, just great. And now I know that one. So useful.
I'm hoping to get Fuzz Rana to come on and let me interview him and put it into a bite-sized bust on dinosaur soft tissue, because he's got a really great text on dinosaur soft tissue in the age of the year. And it turns out the more you learn about dinosaur soft tissue, the more you realize, wait a second, this is not helping their case, because we should be finding gobs of fresh DNA in everything. And there's a lot more to that, but.
Excellent. Go ahead.
What I love about or one of my favorite funny bits about the polystrate fossils is, you know how we point out that creationism is usually about 30 years out of date? Yes. On that one, they're about 130 years out of date.
Yeah.
Incredible. Incredible.
Yeah, we figured that one out a long time ago. So let's see. I am right now between semesters, which is great, which means I can actually do things. So those of you who have been following me for a while may have noticed that I was kind of a little silent for a while, because during the semester, as long as we're doing the remote teaching thing, I'm putting out lots of videos each week, but they're all for class. It's like 2 hours of content each week, but it's all for class instead of for this. So, but when we're not doing real semester work, I try to get stuff out, do one thing a week. So I got a couple of creation myths last couple of weeks. We did what did we do? We did citrate, we did lactase persistence. We got this week. Next week, I've got 2 creation myths that are ready to go. So I just a matter of recording them and doing them. So I'll get those out at some point. We'll do more stuff like this coming up, and I'm going to do something fun for that's right. I'm going to talk with David Neff at some point in the near future, and we're going to do something fun because I hit, again, I referenced it at the very beginning. I guested for Pelagia a couple weeks ago, and that boosted me up past 1,000 subs. So we'll do something fun for that milestone. And I'm coming up on 1 year on YouTube, so we'll do a 1K 1 year kind of hanging out thing, something fun. I have an idea of what I think we should all talk about, and that'll be I think a fun conversation. So that's all we got. Thank you all for joining us for this romp through 10 minutes of Rob Carter just approaching the theoretical limit for like the wrong density in a conversation like this. Incredible. So that's all I got, everybody. Thank you for being here. I appreciate all of you, and I will see you soon.
Bye.